Likewise, we can extend it to remaining symbols. The next one is read operation. This is very simple. When you don't want to push, pop or anything, if you just want to read whatever is there in input tape and stack, we can use this read operation. Okay, and then go to the next symbol X, Y and B. From next symbol onwards, you can either go for push operation, pop operation or read operation or any type of operation. So if you see here, for this A and for this C, let us assume a condition like whenever A is there as a present symbol to be read by the finite control head, and the next symbol which is present, the corresponding symbol which is present on the stack is C, don't do any push or pop operation, just read it. Okay, don't remove this A from this input tape, don't remove C from this stack. Okay, so this is called as read operation. Whenever there is no change in the input tape or the stack, this is called as read operation. So we are writing AI, that is input tape symbol and stack symbol. Remember, the order is very important. You have to write the input tape symbol first and then the stack symbol, and then you have to write the slash. Slash indicates whatever is there after slash, this is a output. It just differentiates the input and the output. In some textbooks you find arrow, in some textbooks you use slash. Okay, in general, in most of the problems we use this slash notation. Okay, so since you are not changing anything in the stack, the status of the stack is you have to write only the top symbol which is on the stack. So this is C itself. The next one, you have the X. From X, X is the next our finite control. After reading A, it goes to the next symbol X, and the corresponding symbol on the stack is C. Either you can remove X and C, do pop operation, or you can just put X over C and do push operation. Depending upon the problem, we are going to choose these operations. Then if you push X on C, then X will be on top of the C, and the output will be XC. And if you want to pop, after X is moved onto the stack, it will be removed from this input tape and your control head now moves to Y. Then compare Y and X. You can add either Y on X, or you can either remove this. So if you want to remove, you have to remove Y and X simultaneously, and this cell is empty now. Show this status of the stack as our output. So likewise, remaining symbols after read operation, whatever symbols are there, for those symbols you can apply any of the operation. Either you can apply push, pop, read or replace. Any of these four can be applied to the remaining symbols. And the transition is same like the previous one. Take the present state, two inputs A and C, that is input tape symbol, stack symbol, and it is leading to the next state Q1. And since there is no change in the stack, we are writing it as C only. And remember that whenever the stack symbol and the status of the stack symbol, when both are same, it means you have done a read operation. Okay. If you have two symbols over here, it is a push operation. If you have epsilon, it is a pop operation. If the stack symbol and the output symbol both are of same notation, it means it is a read operation. Then the last one is replace operation. We normally use this during NPDA problems, that is called as non-deterministic problems. Okay, we shall see about this when we are doing those problems. So these are the input tapes. Replacing is similar to your push. Okay, but when you are trying to push an element into the stack, instead of pushing the symbol as it is, we are giving some other name to this input tape symbol and we are pushing it. If you see here, we have 0 0 1 1. I want to push all these things into the input tape. So 0 I want to push, I will change 0 to a notation. I will assume 0 equal to blue color, 1 equal to green color, and whenever 0 I want to push, I will push it as B instead of writing it as 0. Second, then after pushing it, this will be removed, and then this is the status of the stack. Then again I want to push this second 0. Second 0 I am considering again it as a blue. So whenever I want to push the second 0, I will push it in this way, and this is the status. Then first one is there. For 1 I am assuming let 1 represent the green color, so I am writing it as G. So I will remove this one, I will push as into the stack, and I will write it as G instead of 1. Then next one is there. If you want to again push it over this, remove this, add G over here. Okay, so same thing we have written over here. 0 is there, our initial symbol, Z0 is the next symbol. So write it as BZ0, this is a status, that is topmost symbol we are writing. Same as a push operation, we have to show two symbols. Then second 0 is there, I am writing it as BB. So second is 0, comma status of the stack is B. When it is push, this is a status, and for push operation or replace operation, you have to show only the topmost two elements only. No need to show the remaining elements, so just show BB. Then 1 is there, first one is there, I want to push over this, I'll get GBBZ0, that I am writing. So 1 is there, you can write it as 1 comma B, it comes G comma B. Similarly for second one, you can write it as 1G GB. Okay, and when the total it is completed, when there is no more symbol in the input tab, you can simply write epsilon comma Z0, and you can simply move this Z0 to final state. It means you are just reading the Z0. Whenever simply Z0 is present in the stack, okay, so we will simply read it. Okay, so up to here, from here to here, these things are considering as replacement operations. This is just a general notation which we use to end up the transition. This is not a replacement operation. Okay. So the transitions are same way, present state Q0, 0, and Z0 is our inputs. Then next one is the transition state, it is moving towards the next state Q1, and the output is PZ0. So same thing, all these transitions are converted to this form, and these are called as PDA moves and transition moves. So these are all the 4 types of operations which we use, and mostly we use push, pop and read operation only in most of the problems. Thank you.